Hello, good evening, class. This is Cbse, your own chemistry tutor, and today I am here with a new topic. As you can see, it is about metals and non-metals. So you have learned that in on the earth, all substance is called matter, right? Matter is something which occupies space and has mass. Okay. And this matter can be divided into two. All these things you have learned in smaller classes as pure substances and mixtures. And among pure substance, we have again dividing it into two called elements and compounds. And you know that matter is made up of atoms, and that is the smallest particle of an atom or a molecule if it's in the case of compounds. So elements have same kind of atoms, and if a substance is made up of two or more different kind of atoms, then we call it as a compound. So elements can be further classified into two. You know that on Earth there are 118 elements and they are all arranged in a periodic table according to its physical and chemical properties. And what are the two types of elements? Main two types are, as you can see, it is the metals and the non-metals. In a periodic table, you can find metals on the left-hand side of the periodic table and non-metals towards the right-hand side. And in between, there are other type of metals, a few which has both the characteristics of metals and non-metals, and those are called metalloids. I'm sure that you all know about all these things. So in this chapter of class 10th Cbse, we are going to deal with metals, mostly about the physical properties of metals. So our learning objective will be physical properties of metals and two, chemical properties of metals. So in chemical properties, the metals, how it reacts with various substances is what we are going to learn. How will a metal burn in presence of oxygen, or what is the reaction of a metal with oxygen, then with water, then with acids, then with other metals or other non-metals. Okay, so how metals react is what we study in chemical properties of metals. Okay, so let's get into our topic more. Physical properties of metal you have been studying from smaller classes. You know somewhat about it. So I thought instead of giving a lecture, let's have a metal quiz. Are you all ready? I will be giving, there will be clues given. Obviously, you can see there will be clues given. And after we answer that, I will be explaining about it more. Okay. So, instruction are name the metal property described in each question. Okay. What are the properties? Physical properties. Okay. So, what property? First question is what property of the metal to be hammered into allows the metals to be hammered into sheets? So, for example, they have given aluminium foil. Okay, aluminum foil is given as an example. So, hammering of metal, solid metal into sheets is called, yes, it starts with the letter M, malleability. Most of the metals can be are malleable. It can be made or hammered into thin sheets. You always use aluminum foil for packing your lunches, or if you get order food from outside, also we will be getting it in aluminum foil, right? So that is called malleability. Can you name the most malleable metal? It is actually silver. Okay. Now, next property. What characteristics lets a metal to be drawn into thin wires? Copper wire is an example. Copper wiring is used in connections. You get to give connections in an electric circuit or in our homes for making domestic circuit. Copper wires are used and it is used as very thin wires. So we draw it into wires. What is that property called? Yes, it is called ductility. Or if you say that copper metal is ductile. And can you tell me which is the most ductile one? It is none other than our gold. If you have 1 gram of gold with us, you can draw it into thinner wires such that the length of the wire will be 2 kilometer long. Oh my God, that is too much, right? Yes, if you draw it into thin wires, you can draw it to up till 2 kilometers of length. Okay. Next, what term describes a metal's shiny appearance when polished? You say, some of the metals like gold, silver, platinum, all shines. Yes. Which one is that? What is that property called? Described as luxure or lustrous, you say. Okay. Metals have got shiny appearance. We all know about that. Can you name me a non-metal which has a shiny appearance? Non-metals which are shiny. Obviously, yes, the diamond, which is made of carbon, is shiny. Then graphite also has some kind of shiny appearance, and also iodine. Okay, now next question. What property makes metals produce ringing sound when it is struck? When you will struck like this, you have heard. And the normal older days, we have got a bell like that, hanging bell, and our peon in the school will go and ring it when it is time for the next class, right? So, what is untouched bells? Of course, you have seen. Even the electric bells, that gong is made of a metal, a hammer is made of a metal. So, the ringing sound is due to, and that property is called, we say that metals are sonorous. Sono means sound, something related to sound, that it makes a cling sound. Okay, fifth question. What ability allows a metal to transmit heat and electricity well? So we say if it is a good, if a metal transmit heat easily, we will say like a name for that. If it transmits electricity, we say a name for that. What is it? Metals are conductors. Conductors of heat, conductors of electricity, because they have got what? Small particles, moving particles, charged particles, the electrons. Okay, now, and metals usually transmit heat and electricity. There is one non-metal. Non-metals usually does not, but Graphite is an example. Graphite is a conductor of electricity, even though it is a non-metal. Okay, most metals are hard. Yes, you have seen, you have these cases. See, the watch is made up of a metal. It's written stainless steel here. Yes, stainless steel is actually made of iron and carbon. It's an alloy. So it is hard, as you can see. But which are the two soft metals which are good enough? It can be cut with a knife. Yes, these questions are almost always asked in GK quiz and all. Yes, it is sodium and potassium. In between, can I ask you what is the symbol of sodium and potassium? And it is very necessary for us to know the symbols because we need to have to symbols and also formulas because we need to write down a lot of reactions, equations of reactions where these compounds are written in their chemical formula. Okay, chemical formula is written. We know how to write it. All those things you have studied in ninth standard, and also we are brushing up your skills before 10th standard class. We need to know all these things. Okay. Okay. So, seventh question. What do we call a high temperature at which the metal change from solid to liquid? That highest temperature. Iron has got 1538 degrees Celsius. You need to heat it, then only it will change into liquid state. Yes, it's melting point. So melting point of metals are usually very high. Okay, now what property makes metals resistant to scratching or bending? It is not easy to bend a metal because I'll tell you about this. It is the hardness or toughness, if you say. Okay. Now, what state of matter are most metals in room temperature? Can anyone tell? Yes, obviously, it is in solid state. Okay. So, is there any exemptions? Of course, there are, right? Metals are mostly hard, but there is a metal which is in liquid form, or we call it as liquid metal, or in other language, you can call it as hydrogyrum, or its symbol is Hg. And what is that metal? It is mercury. Okay, mercury that we use. I'll write it here. Mercury, and its symbol is Hg from its Latin name hydrogyrum, means hydra, water. A metal which is in a liquid form, okay, or like water. And there are other things, other solids, other metals which are solids. Liquids. If you take it in our hand, it will be because of the temperature of our hand, that is our body temperature, 37 degrees Celsius, it will turn into a liquid. And those examples are gallium and thallium. Okay. So, and that was about the physical properties of metals. Mostly metals are hard, but exceptions here again. Exceptions are potassium and sodium. It is too soft because it can be cut with a knife. And then some are metals are it is in liquid form. Those are mercury, gallium, and thallium. And again, usually, non-metals are considered to be in a gaseous state or liquid state, but the hardest substance on earth, if you believe me, it is diamond. which is a allotrope of carbon. Okay, carbon is found in three major forms like coal, graphite, and also some other diamond. And diamond is the hardest substance, and that is a non-metal. Okay, so these were the properties. What all were the properties? Malleability, ductility, lustrous, sonorous, conductors. It has got high melting point. Most of the metals are hard. It gives tough. They are solid in normal room temperature, and there are some exceptions to it. And always exceptions, asking exceptions are the favorite questions that your teacher or the whoever sets the exam question paper, exceptions, they love exceptions. Okay, so you need to study about all the properties, especially exceptions. Okay, now we are done with the physical properties. Let's go into the chemical properties one by one. There are a lot and lots of chemical equations, and so here we are going to study about metals. So there are 92. I have told you that there are 118 elements or 119. The scientists are still finding it out. So among them, only a few are man-made, and in that 95 are metals. Okay. So if you remember how a periodic table looks, on the left hand side, middle, down portion, you have two strips over there. All are metals. Okay. Lots and lots of metals are there, and we are picking a certain metal and we are going to study about it. Okay. So mostly we are going to take what all your teacher is taking: sodium, magnesium, calcium, copper, aluminum, zinc, all those things, and we are doing the experiment. Some are very dangerous, so we need to be careful. Mostly we will not be allowed to do it in class, but you have to go to the lab. You have to wear all these things because metals are, most of the metals, or there are highly reactive metals, and if you just keep it outside, it should be kept in a particular, it's safe. You have to keep these metals very safe because it is highly reactive. It will be bursting or it will catch fire easily. There are metals which catch fire easily, so it is better we will be careful while we are dealing with it. Okay, so first one, what is a chemical properties of matter? First property, we are going to learn about reactions with air or oxygen. If I may pick one component of air, how metals are going to react in air. So first, the metals that we are taking is sodium. Sodium is there, potassium is there, calcium, magnesium, aluminium, then what? Uh, there will be zinc, iron, Fe, and then what? What else? Lead, hydrogen. It is hydrogen can be a metal and it can be considered as a non-metal also, because hydrogen has only one electron. Sometimes it gives electron, sometimes it can also accept electron. So hydrogen is there in that this thing. And then comes copper is there, silver is there, mercury is there, silver, gold, and platinum. Okay, so our teacher is going to pick some of these and we are going to learn. Remember that there are 95 metals. We are not going to learn about all those things. We are going to learn about certain elements, and then we will be comparing it. The other metals that we are not studying will mostly have the characteristics of these metals that we are studying. Okay. First is we are going to take the reaction of sodium with oxygen. Oh my God, it is very dangerous if you take sodium oxide and keep it open in air or open to the place openly in a atmosphere. It will vigorously catch fire, and it is an exotherm. It's like a bomb kept, huh? So it will vigorously catch fire, and it is highly exothermic. So what is exothermic? Heat is evolved. It will be vigorously reacting. So what is the equation? Sodium reacting with oxygen. Sodium reacts with oxygen to form sodium oxide. Okay, so you know the name. And how are you going to write the formula for that? So in earlier classes, you have learned that what? You know the name, right? We'll write the name. Sodium and oxide ion is formed. So you know that valency of sodium is +1 and valency of oxygen is -2. You have learned in ninth standard. That is a very important topic. Only then you will be able to write the chemical formula. Otherwise, you have to by heart it, and that is a big mess. That's going to be a very big mess. So what we have to do is, if we get to, this is a normal combination reaction where one reactant reacts with the next one to give a product, right? So there is sodium, there is oxygen, they both come together to form sodium oxide. Fine. We have got the name, and then you are going to write down the formula. So crossing over, sodium gets the valency number of oxygen, and oxygen gets the valency number of sodium, that is 1. So Na plus O2 giving Na2O. Okay. Now, next step is that we need to balance the equation. First, in the first chapter, you have learned about balancing the equation. So this side, how many atoms are there, which should be equal to the atoms on the other side as well, right? So if you balance here, it is only here there is 2, here only 1. So we made it 2. Then you are coming back. Then you can see here there is 4 number of what sodium atom. So we make it. Okay, then can you tell me what will be the reaction between sodium and also potassium? Will this show the same rigorous reaction when it is kept outside, open in the air? We will get K2O, same as this, okay? And balancing it, we will be getting a chemical equation like this. And also we can write plus heat is produced. Okay. Now, you have both these. When do you remember studying about magnesium oxide, burning of magnesium in with a dazzling white flame in seventh standard, and then that product which is formed is, yeah, you have already studied about it, right? Magnesium burns. We'll just show the magnesium ribbon onto the flame, and then it starts uh, burning, and it will be so, it's like just we look at the tube light where our eyes will be like, bright, and we'll not be able to see something, that dazzling white color of flame is produced by magnesium. And we have already studied Mg plus O2 giving MgO. And if you know the formula, how to write the formula, this thing is a piece of cake. Okay, now these things. So, in that, when we were in smaller classes, we were asked to take this magnesium ion and add it to water. And we will get another uh, object. If you say X or Y, a new product is formed. When this magnesium oxide reacts with water, a new product is formed, and that product turned red litmus blue. Which substance turns red litmus blue? Yes, it is a base. So we can say that when the product magnesium oxide, which is formed by the reaction of magnesium and oxygen, is dissolved in water or combines with water to form a new product, a new substance, and that is a base. So, here, what base is formed? Can you tell me? Yes, of course, there is only base, magnesium hydroxide. Again, if you can do the same thing with sodium oxide, if you react it with water, you will get sodium hydroxide. And then if you react with heat, I mean, sorry, we react K2O also, we will get potassium hydroxide. Potassium hydroxide reacting with water, we will get KOH, right? So we can also say that these oxides of sodium, oxide of magnesium, and all are basic oxide. That is, it will be react, can react. It is a base. It has more basic character. It, even though it is a salt, it has a basic character because when it is reacted with water, it will form a base. Okay, so most of the metal atoms are basic in nature, and among that, some it is there are some insoluble also oxides, and they react with acids. So this basic oxide react with acids to form salt and water. Okay, now another example given here. Okay, if I ask what about what happens to calcium, calcium when react with oxygen, we will get calcium oxide, and calcium oxide again, if it is dissolved in water, what will you get? Calcium hydroxide, right? Similarly, we can, if you know the basic uh, reactions happening, then we will be able to write down the reactions of other metals as well. That I have told you earlier. Okay, you don't need to study about all the things, but some basic reactions so that it will be easier for us to predict what some reactant, what product will be formed in later on. Okay, okay now. So what about copper? You have seen we have vessels made up of copper in our kitchen, right? Copper is that shiny, golden, brownish vessels you have. We used to put it on fire, right? For cooking and all, we use copper vessels. Will it catch fire like sodium? And that will be a disaster in the kitchen, right? No, nobody will. No, nothing will happen. Otherwise, nobody will make vessels out of copper, right? Copper, what happens if you heat it? You have seen that after cooking and all, we will be getting a black coating of something outside on over the, I mean, on the bottom layer of the vessel, right? And what will be that if it is a if it a copper vessel is taken, or if you take a copper strip or a copper wire and you will be showing it to the flame, what will happen first is that the copper will turn black. That a layer will be found at the outermost. If it is a strip, its outermost region will be turned black in color. And what is that? It is copper oxide. Or if you leave copper out in the atmosphere, sometimes it can change into copper carbonate, or sometimes it will change into copper oxide, which means it forms a black coating. Okay, this copper oxide is also a basic oxide. This does not dissolve in water, but this copper oxide, if you make it react with HCl, an acid, you will get salt and water as usual. Whatever the this thing is, what does the neutralization reaction says? If a base reacts with acid, we get salt and water. Similarly, this basic oxide is also has also the property of a base, so it can react with metals to form metal salts. Okay. Now, there is another thing about aluminium. What do you know about aluminium? Aluminium also If it is left, it don't have to be heated. Slow process, aluminum can form a outer layer, okay, of aluminum oxide. It just forms a layer. If you take a vessel or a big block of aluminum and it is made to react with oxygen, only only a outer thickness of 5 nanometer thick, you will get a layer of aluminum oxide with layer which covers the metal. And then what happens is that that layer will further protect this aluminum metal from further oxidation. Even the aluminum vessels we have at home, it is always open in there. What is actually happening here is that already they have a coating. It has a coating. The outer layer, outer atoms of aluminum will be reacting with what? See this reaction? Will be reacting with oxygen and forming a coating of aluminum oxide. So 4Al plus 3O2 gives Al2O3. Okay, then again, what about its basic or acidic property? If I say aluminum is amphoteric, what does it mean? Do you know about amphibians? Frog is an example of amphibians, meaning it can live both on earth, on land, as well as in water. Similar is the case of aluminium. The oxide of aluminium, actually, the oxide is aluminium. It acts as a base as well as basic oxide, or it can be acidic oxide. For example, this aluminium oxide can react with hydrochloric acid to form aluminium chloride plus water. So, what is happening here? It sometimes acts as, in this case, this aluminium oxide is acting as a base and it reacts with HCl to give aluminium chloride plus H2O. So you need to balance this equation. Balancing of equation is very, very, very important. So if you can learn by heart is a little bit tedious, but still you just need to know. Or if you can't remember it, you need to balance the equation and write it properly. Okay, so this reaction says that it is a basic oxide. Okay, then in another case, the same aluminium can also react with the base. NaOH is a strong base. It reacts with a strong base to form sodium. So metal comes first, then comes the later aluminate. So there are two metals and one which is a special kind of compound which is formed, and the formula is NaAlO2 plus water. Again, this needs to be balanced. You will get Al2O3 plus 2NaOH, giving sodium aluminate. Similar reaction. There is another metal oxide which also gives the similar reaction. Can you name what that is? It is our own zinc. Zinc. Zinc oxide. Because zinc, when reacting with oxygen, we get zinc oxide is an NO. Okay. The zinc oxide can also react with HCl. Zinc oxide will also react with NaOH. Here you get zinc chloride plus water. Here you will get sodium zingate. Okay. And sodium zingate and plus water. Okay. Now, those were the reactions we need to know in this about amphoteric nature. That is very, very important. And also, what happens to the sodium and potassium if it is left uncovered in atmosphere? It will, yes, it will vigorously react. MgO, Mg, metal, magnesium ribbon. What will it have? What will happen to it? It will be burning with the Vaseline dazzling. Yes. And calcium oxide will be formed. Calcium plus oxygen is a slow reaction, will be forming calcium oxide, which in turn, if it is reacting with water, we will get calcium hydroxide. And copper, when it is burned, it will only form a black outer covering, which is copper oxide. And copper oxide, all these basic oxide are mostly basic. Metal oxides are basic in nature. Exception is that aluminum and zinc will react with both acid and base to form salt and water. And because of that, it is called an amphoteric oxide. And again, iron, if you heat iron, what will happen? Iron will be melting. Okay, it will melt. And if you put iron filings to the fire, if you sprinkle iron filings, then they will be vigorous. It will burn vigorously. Then another thing, gold and silver. You can see, gold and silver does not react with oxygen. Well, if you burn it, it will melt. Or else if you left it there, then nothing is going. No coating will be appearing on gold or silver. Silver might react with sulfide to form a black coating, but gold never. Not even at high temperature. So you need to know about all those things. It's just a reaction, and there are so lots of reactions, lots of new names and equations, balance of equation. So why you have to write it down, you have to know the basics, symbols, chemical formula, and how to balance each of these. Okay. Now, anodizing of aluminium. You have already said that aluminium, when reacts with oxygen, it forms a coat of aluminum oxide on the top layer. Okay, so that aluminum metal which is inside that layer will be protected. And this protection, if you want to make a vessel, it can happen naturally or it can be made to happen. Okay. So that process is called anodizing of aluminium. Anodizing is a process used to increase the thickness of the natural oxide layer. Okay. Increase the thickness of natural oxide so that what can we do because of that? We can protect that metal from, anodizing is a process used to increase the thickness of natural oxide layer on the surface of aluminium. This oxide layer protects the metal from corrosion and enhance its appearance. So in that process, we need to do an electrolysis is being done there. You have studied in 8th standard about electrolysis. And also later in this chapter, we'll be studying about electrolysis where we have to refine metals. So the process is that aluminium is made to kept as an anode in the electrolytic series, and anode is the place where oxidation takes place. And dilute sulfuric acid is taken as the liquid, which dissociates to give oxygen. And then electric current is passed. Oxygen gas is evolved at the anode. While evolving, that oxygen gas reacts with aluminum article to form a thicker outer layer of oxygen. So you do not need to learn the principle or in detail, but you need to know what is anodizing of aluminum, and that is a process used to protect. Yeah, what are the benefits? It prevents corrosion, increases the durability and resistance to wear and tear. And the oxide layer also can absorb dyes, making the surface decorative. If you have an oxidized aluminum, we can apply dye on it. We can make it into different colors like blue color aluminum bottles, or maybe our phone case. Aluminum is very hard. It's a harder material. It's even used for making parts of an aircraft, okay, because of its lightweight and its hard properties and all. And again, you can color it. Okay, so anodizing makes aluminum more useful for cookware, doors, windows, and electrical appliances. So, this, I think we will wind up the class for today. And this was about the chemical reactions. First chemical reaction, the reaction of metals with air. Okay, we have seen different metals react differently, and that was the reaction. Okay, now we will be learning about another reaction in our next class. Okay, so bye bye.